When engineers first began digging deep inside the Swiss Alps, they encountered something terrifying. At one point, a hidden underground water pocket suddenly burst open, releasing a high-pressure jet that flooded the tunnel within seconds, turning the site into a disaster zone. This was the beginning of what would become one of the greatest engineering challenges in human history: the Gotthard Base Tunnel, stretching 57 kilometers. This is not only the longest railway tunnel ever built, but also one of the deepest, constructed nearly to 0.5 kilometers beneath solid mountains. Because of its extreme difficulty, many experts call it the Mount Everest of engineering. But why was such a massive tunnel even needed? For centuries, the Alps acted like a natural wall across Europe. Trade and travel routes had to pass over steep, zigzag mountain roads where snowstorms and avalanches could shut everything down without warning. Even with bridges and railway tracks, trains struggled to climb steep slopes, making transportation slow and inefficient. As Europe's economy grew, the demand for faster and more reliable connections increased. Northern factories and southern ports depended on each other, but the mountains stood in the way. So engineers made a bold decision to go through the mountain instead of over it. But what sounded like a bold idea quickly turned into a nightmare. Building the Gotthard Base Tunnel meant digging under a mountain nearly 2,500 meters thick. At this depth, the pressure from the rock above is so intense that it can crush structures instantly. Engineers knew they weren't just dealing with stone, they were fighting natural forces never challenged at this scale before. To understand the pressure, they first drilled smaller test tunnels. But instead of staying stable, the surrounding rock began pushing inward, trying to close the tunnel completely. It was like the mountain was healing itself, refusing to be cut open. And that was just the beginning. As the excavation went deeper, temperatures began rising rapidly. At such depths, natural geothermal heat pushed temperatures close to 50 C. In these conditions, workers could only stay inside for short periods before risking heat stroke. Machines also struggled. Overheating equipment, expanding metal, and limited airflow made the environment extremely dangerous. At one point, experts around the world openly declared that building such a long and deep tunnel was impossible. But for Switzerland, this project was not optional, it was necessary for survival. As if pressure and heat were not enough, engineers soon faced their most dangerous enemy: water. Deep inside the mountains, water had been trapped for centuries within cracks in the rock. But this was not normal underground water because of the massive weight of the Alps above it. The pressure inside these water pockets reached extreme levels, up to 900 psi. That is powerful enough to break through concrete like an explosion. During drilling, when machines hit these zones, water would burst out violently, flooding the tunnel in seconds. It was unpredictable and deadly. To solve this, engineers came up with a revolutionary solution: freezing the water before drilling through it. They drilled small pipes into the rock ahead of the tunnel and pumped special freezing liquids through them. Over time, the water inside the cracks turned into solid ice, stabilizing the ground. Now, when the tunnel boring machines moved forward, they could cut through the frozen sections safely. as if it were solid rock. After passing through, engineers reinforced the area with concrete and created drainage paths so that water could flow out safely later. This technique turned one of the most dangerous threats into a controlled process. Another massive challenge was precision. The Gotthard Base Tunnel was so long that it could not be built from one side alone. Engineers had to dig from multiple points across Switzerland, with the goal of meeting perfectly in the middle after 57 kilometers. Even a tiny error could destroy the entire project. If the alignment was off by even a few centimeters, the tunnels would miss each other completely, wasting billions of dollars and years of effort. To prevent this, engineers used advanced laser systems, GPS data, and gyroscopic navigation tools. These technologies allowed teams working deep underground, far apart from each other, to stay perfectly aligned. Every movement was calculated with extreme precision. After years of excavation, the final breakthrough moment came in October 2010, as the last layer of rock was drilled away. Both sides finally connected when measurements were checked. The difference between the two ends was just a few centimeters. This level of accuracy is often compared to hitting a tiny target from dozens of kilometers away. It was one of the most precise engineering achievements ever recorded. After solving rock, heat, and water, engineers discovered another invisible threat: air pressure. When high-speed trains travel through a long tunnel like the Gotthard Base Tunnel, they push air forward at incredible force. Inside a confined space, this creates powerful shock waves, if not controlled. These waves could shatter train windows or damage the structure itself. To solve this, engineers completely redesigned the tunnel system. Instead of building a single tunnel, they constructed two parallel tunnels, connected by cross passages every few hundred meters. These connections allow air to move freely, reducing pressure buildup. In addition, special ventilation shafts were added to release excess air. This system ensures that when a train enters the tunnel at high speed, the air has somewhere to escape, preventing dangerous pressure waves. Without this solution, the entire project could have failed even after completion. It proved that in engineering, not all dangers are visible. Sometimes, the biggest threat is something you cannot even see, like air. The construction scale of the Gotthard Base Tunnel was enormous. During excavation, engineers removed nearly 30 million tons of rock from inside the Alps. This amount of material was so large that it could form an entirely new mountain. Managing this waste became a major operation. Hundreds of trucks worked day and night to transport debris out of the tunnel. Some of the material was even reused to create artificial land. At peak construction, around 2,600 workers were working underground at the same time. Conditions were extreme: no sunlight, limited air, constant noise, and high temperatures. Workers had to rely on machines, artificial lighting, and ventilation systems to survive. Despite all safety measures, the project was dangerous. Several workers lost their lives during construction, showing the real human cost behind this achievement. This was not just an engineering project, it was a test of endurance, patience, and human determination over 17 years. The idea of the Gotthard Base Tunnel was first proposed in the 1940s, but actual construction began in 1993. For decades, the project remained impossible due to technological limitations. But as engineering advanced, Switzerland decided to move forward with one of the most ambitious infrastructure projects ever attempted. Special tunnel boring machines were built specifically for this task. These machines were massive, some reaching for 100 meters in length, with cutting heads as tall as multi-story buildings. Despite their size and power, progress was slow. Sometimes, the machines advanced only a few meters per day due to the hardness of the rock and safety requirements. The total cost of the project reached around $12.5 billion, making it one of the most expensive tunnel projects in history. But this was not just about building a tunnel. Switzerland wanted to transform European transportation, reducing travel time, improving trade efficiency, and shifting cargo transport from roads to rail to reduce pollution. It was a long-term investment in the future. When the Gotthard Base Tunnel finally opened, it completely changed transportation across Europe. Trains could now travel through the Alps quickly and safely, avoiding dangerous mountain routes. Travel time was reduced, and freight transport became faster and more efficient. Thousands of trucks were removed from mountain roads, reducing pollution and environmental damage. But beyond its practical benefits, the tunnel represents something greater. It is proof that even the most impossible challenges can be overcome with innovation and persistence. Engineers faced extreme pressure, deadly heat, explosive water, and invisible air forces, and found solutions to each one. After 17 years of construction, billions of dollars, and the efforts of thousands of workers, the project was completed with remarkable precision. Today, it stands as one of the greatest engineering achievements in the world. Not just a tunnel, but a symbol of what humans can achieve when they refuse to accept limits.